Good morning, students. Last class we discussed quicksort. Okay, now we go for the STRASSEN'S matrix multiplication. Okay, see in the STRASSEN'S matrix multiplication, that is, let A and B. STRASSEN'S matrix multiplication. See, let A and B be the two n by n matrix. The product matrix C equal to AB is calculated by using the formula. Okay, so whose ith element is founded by the taking of the elements, it will be produced to the particular. So whose ith element is the founded by by taking the elements in ith row and jth column of the B and multiply them. See, C of I comma j equal to sigma 1 less than or equal to k less than or equal to n A of I comma k B of k comma j for every all I and j between 1 and n. The time complexity of matrix multiplication is big O of n cube. So normally matrix multiplication time complexity is big O of n cube. So whenever the STRASSEN'S using of matrix multiplication, the time complexity is big O of n power 2.81. So the complexity will be reduced whenever we using the STRASSEN'S matrix multiplication. See, the divide and conquer strategy suggests a way to compute the product of n by n matrices. Assume that is there exists non-negative integer such that n equal to 2 power k. Okay, in case n is not of 2, then the addition of row and columns of zeros can be added to the both multiplications, and so that the resulting dimensions are the power of 2. So imagine A and B are each partition of the particular constructions. Okay, how to calculate the matrix multiplication is C of I comma j equal to A of I k into B of kj. When go for the normal matrix multiplication, the time complexity is big O of n cube. Whenever we go for the STRASSEN'S, that is the complexity is reduced, that is big O of n power 2.81. Okay. See, we assume that n is a power of 2. In case n is not a power of 2, then enough rows and columns of 0 can be added to both A and B, so that the resulting dimensions are the powers of 2. If n equal to 2, then the following formula as computed using a matrix multiplication operation, the elements of A and B. If n is greater than 2, then the elements are partitioned into submatrix, that is n by 2 into n by 2. Since n is a power of 2, this product can be recursively computed using the formula. This algorithm will continue applying itself to smaller submatrix until n becomes suitable of small of n equal to 2, so that the product is computed directly. Okay. See the formula of A11, A12, A21, A22 and B11, B12, B21, B22, that equal to C11, C12, C21, C22. So how calculate that? C11 is A11, B11 plus A12, B21 and C12 equal to A11, B12 plus A12, B22. Then C21 equal to A21, B11 plus A22, B21. Then C22 equal to A21, B12 plus A22, B22. Okay. Here the multiplication of operations takes 8 multiplications. Here see 8. 1, 2, 3, 4, 5, 6, 7, 8 multiplications and 4 additions. 1, 2, 3, 4. These are the 4 additions, 8 multiplications. Okay, to compute the result. Okay, the overall compute time of T of n of the matrix multiplication using divide and conquer algorithm, it is given to the relation T of n equal to B, n is n less than or equal to 2, then 8t of n by 2 plus t n square is n greater than or equal to 2. That is the big O of n cube. Whenever we have to compute of these multiplications, the time complexity is big O of n cube. See here, C of I j, A of I k, B of k, I and j between I and j. The time complexity for the matrix multiplication is big O of n cube. Okay, see here. Here we can take 8 multiplications: A11, B11, A11, B12, A21, B11, A21, B12, A12, B21, A12, B22, A22, B21, A22, B22. That is C11, C12, C21, C2. Here you can apply 8 multiplications plus 4 additions. In that way, we have to compute the time complexity, that is T of n, using of these matrix multiplication. We can go for the we are saying the big O of n cube. Okay. See, to compute AB, we need to perform 8 multiplications and 4 additions of n by 2 into n by 2 matrices. Okay, since 2 n by 2 into n by 2 matrices can be added in the time Cn square for the sum constant C, the overall computing time T of n of the resulting divide and conquer algorithm is given by the recurrence, that is T of n equal to B 8t of n by 2 plus Cn square. C is the constant value. So here where B and C are the constant values. C. Matrix multiplication are more expensive than the matrix addition, that is big O of n cube. We can attempt to reformulate the equation for Cij so as to have fewer multiplications and possibly more additions. Okay, then go for the STRASSEN'S matrix multiplication. See, STRASSEN'S has discovered a way to compute Cij of equation then using only 7 multiplications and 8 additions or subtractions. See here, P equal to A11 plus A12 into B11 plus B22. Then Q equal to A12 plus A22 into B11, R equal to A11 into B12 minus B22, then S equal to A22 into B21 minus B11, then T equal to A11 plus A12 into B22, then U equal to A21 minus A11 into B11 plus B12, then V equal to A12 minus A22 into B21 plus B22. Okay, here totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 additions and subtractions, see here. And 18 additions and subtractions and 7 multiplications. See, 1, 2, 3, 4, 5, 6, 7. In go for the STRASSEN'S matrix multiplication, we using the 18 addition subtractions and 7 multiplications. Then how to calculate this one is, see here, C11 equal to P plus S minus T plus V, C12 equal to R plus T, C21 equal to Q plus T, and C22 equal to P plus R minus Q plus V. Okay, in normal multiplication we go for the 8 multiplications and 4 additions. Then that process we have to calculate the time complexity is big O of n cube. In that way the STRASSEN'S will becomes, he has to reduce that complexity. He wants to implement some formulas, that is here we can use the 18 subtraction and additions and 7 multiplications. Okay, see how it construct this, the can take P Q R S T U V, then C11 is P S T V, C12 R T, C21 Q plus T, C22 P plus R minus Q plus V. Okay, likewise we have the Strassens using these 18 additions or subtractions and 7 multiplications. Okay, the resulting of the recurrence relation for T of n is T of n equal to B, n less than or equal to 2, and 7T of n by 2 plus a n square, that is n greater than 2, where a and b are the constants. Working with this formula we get T of n equal to a n square of 1 plus 7 by 4 plus 7 by 4 whole square plus and so on 7 by 4 k minus 1 plus 7 power k into t of 1. Likewise cn log 4 base 2 plus 7 base 2 minus log 4 base 2 plus n log 7 base 2, that equal to big O of n log 7 base 2 is approximately big O of n power 2.81. But normal in multiplication we get big O of n cube, but here we get big O of n power 2.81. Okay, so automatically in the using of Strassens it will be reduced to the complexity. In normal we can use the 8 multiplications and 4 additions. See, C11 is A11 B11 plus A12 B21, C12 equal to A11 B12 plus A12 B22, and C21 equal to A21 B11 plus A22 B21, and C22 equal to A21 B12 plus A22 B22. So 8 multiplications, 4 additions in normal multiplication. In that we can calculate the time complexity is big O of n cube. In that the Strassens go for implemented to compute Cij, you can only using 7 multiplications and 18 addition or subtractions. Okay, see here P equal to A11 plus A12 and B11 plus B22, A12 plus A22 B11, A11 B12 minus B22, A22 B21 minus B11, A11 plus A12 B22, and A21 minus A11 B11 plus B12, and A12 minus A22 into B21 plus B22. Then C11 equal to P plus S minus T plus V, C12 R plus T, C21 Q plus T, C22 P plus R minus Q plus V. Okay, so here we can use 18 addition, subtractions and 7 multiplication. In that way we have to calculate the time complexity is big O of n power 2.81. Normally it is big O of n power n cube, but here n power 2.81. Whenever we using the Strassens, we can reduce to the time complexity. Okay. Next one, selection sort. In selection sort, algorithm starts by the comparing to the two elements of an array and swapping it necessary. That is, if we want to sort the elements of an array is ascending order, and if the first array is greater than or equal to second, then need to swap the elements, the first element smaller than to the second element, leave the element as it, and we are giving the elements e of 1 is to n are required to determine the ith element is the smallest element. First of all, we have to compare to the first element, second element, and first to second, first to third. Likewise, we can select the elements. Okay, see here we are given n elements, e of 1 is to n, and are required to determine the kth is the smallest element. If the partitioning element v is positioned at e of j, then j minus 1 elements are less than or equal to e of j, and n minus j elements are greater than or equal to e of j. If k less than j, then the kth smallest element is in e of 1 is to j minus 1. if k equal to j, then a of j is the kth smallest element, and if k less than j, then the kth smallest element is the k minus j smallest element in e of j plus 1 is to n. Okay. See, the algorithm places the kth smallest element into position e of k and partition the remaining elements so that e of I less than equal to e of k and 1 less than I less than k, and e of j greater than equal to e of k and k less than I is equal to 1. So what is an algorithm of selection sort? See, algorithm of select a comma n comma k. Here they select the kth smallest element of e of 1 is to n and places it in the kth position of e of. The remaining elements are rearranged such that e of m less than or equal to e of k for 1 less than or equal to m less than k, and e of m greater than or equal to e of k for k less than m less than n. So how can select? First of all, we go for low equal to 1, then up equal to n plus 1, then e of n plus 1 equal to infinity. That is u of n plus 1 is set to the infinity value. Okay, so first is the low, up equal to n plus 1. Okay, then each time the loop is entered, that is 1 less than low, less than or equal to k, less than or equal to up, less than or equal to n plus 1. So j equal to partition of a comma low comma up. Then if k equal to j, then return if else. If k less than j, then up equal to j. That is the j is the new upper limit, else low equal to j plus 1. J plus 1 is the new lower limit until false statement. So whenever we go for the selection of, we can tracing, like we can compare to the elements. Okay, so that is we compare the two elements on array and swapping is necessary. That is the we can sort the elements of array in ascending order. If the first array is greater than to second array, then we will compare to the swapping to the elements. Okay, see for example, the given elements are 60, 55, 40, 50, 45, see here totally 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Okay, then a of 10 equal to infinity. Then we have to compare these elements. First of all, if we go for the if k equal to 5, then the first call of the position will be sufficient since 65 is placed in the e of 5. Okay, 65 is placed into 2, 3, 4 e of 5. Okay, instead that assume that we can looking for the seventh smallest element of a, that is the k equal to 7. The next invocation of position is partitioned into 6 comma 10, that is 65, 85, 80, 75, 70 and infinity, and the last column of the position 65, 75, and it will be rearranged to the elements. Then selection sort makes the n number of steps of outer the book before the stop. Every stop of the outer look required the finding in minimum is unsorted of the elements. Okay, the resultant of big O of n square is the number of comparisons. The time complexity is big O of n square. Okay, is the selection sort. In selection sort, what we do in selection sort, we can given n elements of a of 1, that is a sort by the comparing of the two elements of an array and swapping its necessary. That is, if you want to sort the given of different of elements array in ascending order, and first we have to arrange the first element is less than or equal to second element, then you need to swap the elements if the first element is smaller than to the second element. So likewise we have to implement the selection sort. Okay. So STRASSEN'S matrix multiplication. In normal multiplication, the time complexity is big O of n cube. Big O of n cube. And when we go in that way, we can use the 8 multiplications and 4 additions. Then go for the STRASSEN'S. It will be implement 7 multiplications and 18 additions or subtractions. In that, compared to STRASSEN'S and normal multiplication, STRASSEN'S multiplication is a better to the he was decreasing to the complexity. Okay, so in that way the normal complexity is big O of n cube, and using for STRASSEN'S multiplication big O of n power 2.81, and go for the selection sort. We can compare the two elements array and swapping the necessary. If the first element is greater than to the less than or equal to second element, then we can need to swap the elements using of algorithm low equal to 1 and up equal to n plus 1, then a of n plus 1 equal to infinity, then j equal to partition of a comma low comma up, then if k equal to j then return, and else if k less than j then up equal to j, else low equal to j plus 1. Okay, likewise we have to implement the selection sort algorithms. Okay, thank you.